So we're ready for our first exercise here. Exercise number 1. Let's find sine A, cosine A, tangent A, and sine B, cosine B, tangent B, where A and B are acute angles in the pictured triangle, actually a pictured right triangle, because we have a 90-degree angle here at C. Now we're going to use SOHCAHTOA to do this, but in order to use SOHCAHTOA, we need to know the length of the hypotenuse. So the hypotenuse is right here, right side little c. So we need c. And you're going to use the Pythagorean theorem to calculate that. We know that the sum of the squares of the legs of the right triangle, so 3 squared plus 2 squared, has to equal the hypotenuse squared, c squared. 9 plus 4 is c squared, 13 is c squared. Now we got to take square roots here. There are actually 2 square roots of 13, but because we're looking for a length can only be positive. So here we know to just take the positive square root. So c is the square root of 13. I just write that in red because that wasn't part of the original problem. We had to figure that out. And now we're gonna use SOHCAHTOA to help us write out these 6 ratios. So let's maybe start with sine A. Sine A, now SOHCAHTOA is sine is opposite over hypotenuse. But now, you know, opposite depends. Opposite to A is not opposite to B and vice versa. So opposite to A is the side that's labeled 3, and the hypotenuse is square root of 13. And 3 over the square root of 13, I'm perfectly happy if you just stop there and leave your answer with that square root in the denominator. 3 over square root of 13. But if you want, and you may have been taught to always do this, if you want to rationalize that denominator, get the square root out of the denominator, you multiply by square root of 13 over square root of 13, which is equal to 1. So you change the look without changing the value, and you get 3 square root of 13 over 13. So that's just fine. Either is okay. You don't have to write both. And also, I'm going to pick up my just cheap calculator here. And I won't always require this, but I just want you to realize that these values have a decimal form. And I get 0.832050 blah 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 blah, right? So if we ever need a decimal form, we're just going to round off. We have to round off. The calculator's even rounding off because the decimals probably go beyond the calculator screen. But it just as a rough rule of thumb, I'm going to round off at 4 decimal places, 0.8321. And I use a squiggly equal sign when I mean approximately equal to. So there's sine of A, cosine of A. So CAH, the K of SOHCAHTOA, is adjacent over hypotenuse. Adjacent to A is the side of 2. Hypotenuse is still square root of 13. 2 over square root of 13 is what we get. And if you rationalize, I always won't write out the steps of rationalizing because we'll see this over and over every once in a while. I will, and if you want more details about it, just send me an email. But here again, you don't have to write both of these. You can stop at 2 over the square root of 13. I kind of think that's simpler than the rationalized form. And I also have a decimal for this, just to compare. It's 0.5547. So just make sure you can get these decimals. You don't need it for this exercise, but we will sometimes need decimal forms. And let's see, tangent of A is TOA of SOHCAHTOA, so opposite over adjacent. So opposite to A is 3, over adjacent is 2, that's 3/2. And of course the decimal for that is just 1.5. So there we got the sine of A, cosine of A, tangent of A, those 3 values. Now we got to do sine of B, cosine of B, tangent of B. We still use SOHCAHTOA. Sine of B is opposite over hypotenuse. But as far as B is concerned, the side that's opposite angle B is the 2 side, right? 2 over hypotenuse is the same for everybody, square root of 13. Of course, that's a value that we saw up above. There is a relationship between these trig functions of A and trig functions of B. And we'll talk more about that a little further on. But for now, just notice, make sure you realize sine of A and sine of B are different. Cosine of B is adjacent over hypotenuse. For B, the adjacent side is 3, so that's 3 over the square root of 13. And I'm not writing the decimals for these because this one also appears up above. So we have its decimal written down. And again, either one is okay. And tangent of B. TOA is opposite over adjacent. And for B, let's see, opposite is 2, adjacent is 3. That's 2 over 3. And let's see if I can do that decimal in my head. That's 0.6667, 2/3. It's actually 0.66666666, on and on forever. Oops, sorry. I got off the screen. And so there we got it. The sine, cosine, tangent for A and B.